Welcome to This Explainer. Today we're tackling something totally mind-bending, the last division, from matter to pure process. We're going to start with a tangible, everyday reality you can physically touch right now and travel all the way down to the abstract, energetic foundation of the universe itself. So get ready to unlearn a lot of what you probably thought you knew about physical reality.
It's a question that seems, well, incredibly simple on the surface. What is the world made of? For roughly 3,000 years, this has been the absolute central, driving question of physics. Philosophers, chemists, physicists, they've all spent millennia trying to figure out what the basic building blocks of our reality actually are. And for the longest time, our answer has relied on what we can call the nesting doll instinct. It's an incredibly intuitive concept that we all hold. We just assume that if you take a substance and divide it, you're naturally going to find smaller, solid pieces of stuff. We all learned in school that water is made of molecules, right? Then we zoom in, and molecules are made of atoms. Zoom in again, atoms are made of a nucleus and electrons. It really feels like an endless sequence of just finding smaller and smaller rocks.
Okay, let's dive into this historical progression because it perfectly maps out our track record with this assumption. Just look at the progression here. Back in 1800, the molecule was thought to be indivisible. Well, wrong. It's composite. By 1890, the atom was the ultimate indivisible unit. Wrong again. Then came the nucleus, then the proton, and the neutron. At literally every single step in modern history, the scientific establishment has labeled a particle as indivisible, only to be proven wrong by the next generation of colliders. So betting against the idea of an indivisible particle hasn't just been some skeptical hunch. It's been an empirically rational bet every single time. That is, until we get to the quark.
But there's a hidden assumption lurking in that historical pattern. You see, at every previous level, from atoms down to protons, dividing meant something very specific. It meant that you could simply add enough energy to overcome whatever force was binding the object together, smash it apart, and then just collect the smaller individual pieces left in the wreckage, mechanical division.
So the crucial point is that when we try to do this exact same mechanical smashing to a quark, the fundamental rules of physics just break down. We hit a massive wall. As our source material beautifully puts it, it is as if nature has built a firewall you may not pass. We literally cannot isolate a single quark to figure out what's inside of it.
And why is that? It's because of the quark anomaly. The force holding quarks together, the strong nuclear force, doesn't behave like gravity or electromagnetism, which actually get weaker the further away you get. No, it strengthens with distance. Imagine pulling a highly resilient rubber band. If you pull hard enough, adding more and more energy, the band doesn't just stretch forever, right? It snaps. But over in the quantum world, the energy you just pumped into that system to pull the quarks apart literally materializes into brand new, full-size quarks right out of the vacuum. You don't get smaller pieces, you just get more quarks. Crazy, right?
This anomaly forces us to ask a profound, entirely new kind of question. What if the pattern of finding smaller stuff doesn't continue forever? Not because we run out of smaller things, but because the very concept of a thing dissolves. What if the ultimate substrate of reality isn't solid matter at all, but just pure, patternless energy?
And this brilliantly illustrates our first proof of this radical idea, annihilation. Take an electron and take its antimatter twin, a positron. When you bring them together, they don't shatter into tiny shards of electron stuff. They completely vanish. They divide themselves entirely out of existence. The only things that remain are two gamma-ray photons, pure electromagnetic energy. This is a clean, undeniable case of matter literally returning to a ground state of energy.
Our second proof takes us to the Large Hadron Collider. Here, scientists are smashing lead ions together at ultra-relativistic speeds. And the result of these collisions? They generate temperatures reaching several trillion degrees. To put that into perspective, that is significantly hotter than the core of a dying, exploding supernova.
Under these immense, hellish temperatures, particles literally lose their physical identities. Protons and neutrons don't break, they melt. They melt into what's known as a quark-gluon plasma. This plasma behaves way less like a collection of distinct particles and much more like an indistinct, swirling liquid of pure color charge. The heat is so intense here that the actual physical mass of the quarks becomes essentially negligible compared to the kinetic energy flying around. It's a state moving rapidly away from matter and straight toward pure energy.
And then we have our third piece of evidence, pair production. This is basically the reverse process of annihilation.
A sufficiently highly energetic photon, which, remember, is pure massless energy, can spontaneously transform itself into an electron and a positron pair right out of thin air. This tells us something absolutely staggering. Energy is logically prior to matter. Photons aren't made of electrons. Electrons are just a possible configuration that energy can take.
Taking all three of these phenomena into account, we arrive at this really beautiful new definition. Matter is just a temporary, localized crystallization of energy. Therefore, dividing matter fundamentally isn't about taking a crystal and breaking it into a million smaller crystals. It's a process of returning that matter to its uncrystallized, purely energetic state.
Section 1. The quantum field reality. There are no particles.
Quantum field theory, or QFT, is the mathematical bedrock of all modern particle physics, and it proposes that fields, not tiny physical balls, are the fundamental entities of reality. These fields exist literally everywhere in spacetime. An electron is not a tiny sphere, it's a temporary localized ripple, an excitation in the universal electron field. A quark is a ripple in the quark field. There is no final hard grain of matter at the bottom of the universe.
To really wrap your head around this, think of this brilliant metaphor from our source. Asking if a quark can be divided into smaller pieces is like asking, can a wave in the ocean be divided into smaller pieces of wave stuff? It's a completely nonsensical question. You can make smaller waves, sure, but you're never going to find a piece of wave stuff. The wave is just a pattern of movement. The underlying reality is the water and the energy you've pumped into it.
So, modern physics leaves us with two philosophical interpretations. Interpretation A is the fundamentalist view. This is your standard textbook view. It says quarks are truly elementary, they carry energy, and the chain of division ends with them. It's safe, it's consistent with the data, but perhaps a bit unimaginative. Then we have interpretation B, the process relationalist. This paradigm shift says the very idea of an elementary particle is a category error. There are no tiny things. There are only fields and energy, and what we call matter is just a stable excitation pattern. Division is just changing that excitation mode until it flattens out into a ground state.
Which leads to an incredibly exciting experimental question. We know about annihilation and melting plasmas, but can we observe ordinary matter, like a single solitary quark, dissolving entirely into pure featureless energy? What would it actually take to unexcite a quark completely?
Now, what's really interesting about this slide is this staggering number, 1.22 times 10 to the 19th power giga-electron volts. This is the theoretical energy scale required to unexcite that quark. It's known as the Planck energy. And to put that into perspective, it is roughly 10 to the 15th power times more energetic than the absolute maximum power of the Large Hadron Collider.
At this Planck limit, our current understanding of physics breaks down entirely. The forces of nature merge. Gravity becomes as strong as electromagnetism. The very smooth fabric of space-time might become turbulent and foam-like. The distinction between a particle and a field completely evaporates. To build a particle accelerator capable of reaching this energy scale, to actually test this in a lab, we would need a machine literally the size of our entire Milky Way galaxy.
But here is the amazing secret. We don't need to build an impossible galaxy-sized machine. Nature already provided one for us, operating at exactly those unthinkable energy levels. That machine was the very birth of the cosmos itself.
Let's move to and see how this builds a timeline of our reality. Go all the way back to 10 to the minus 43 seconds after the Big Bang. The entire universe was at the Planck energy. At this moment, matter did not exist. It literally couldn't. For that first fraction of a picosecond, reality was just a unified, featureless, terrifyingly hot soup of pure energy. It was only later, as the universe expanded and cooled down, that this energy began to locally freeze. It crystallized into the localized patterns of vibrations that we now recognize as matter. The journey of dividing reality doesn't end by finding the ultimate tiny rock at the bottom of the universe. The quark might just be the very last recognizable pattern before a return to total formlessness. As our source material states so perfectly, the chain of division does not end in a smallest thing. It ends in energy.
I want to leave you with this final, incredibly profound thought to ponder today. Take a look at your hands right now. Take a look at the room around you. If you aren't actually made of solid, immutable stuff, but are fundamentally just a beautiful, temporary pattern of vibrating energy fields, how does that change the way you view yourself and your connection to the universe? Thanks for exploring this mind-blowing explainer with me, and keep questioning the nature of your reality.